Good morning to you all. I welcome you all to this 4-week MOOC course on stochastic processing, third session. So previous two sessions we discussed the introduction to random variables, properties of PDF, properties of CDF, some important density and distribution functions, and statistical calculations, mean, variance, standard deviation, kurtosis, skewness, and moment generating function. So today some problems on the things discussed in first two sessions. So first one is determine which of the following are valid distribution functions. I have three problems here. So first one is capital Fx of x. This is a CDF function, cumulative distribution function. Capital Fx of x is equal to 1 minus e power minus x by 2 when x greater than or equal to 0, 0 when x less than 0. Here we should check the properties of cumulative distribution function. That first property is Fx of minus infinity is 0. So here from the equation, given equation, it can be seen that when x less than 0, its value is 0. So Fx of minus infinity is 0. The first property has been verified. Second one, Fx of infinity, substitute in place of x infinity, the equation is 1 minus e power minus x by 2 when x greater than or equal to 0. So substituting 1 minus e power minus infinity. So e power minus x by 2 is there. Substituting x is equal to infinity, e power minus infinity. E power minus infinity is 0. So 1 minus 0, 1. So as per the property, Fx of infinity should be 1. So second property is also verified. And it should be the monotonically increasing function. If you try to plot that 1 minus e power minus x by 2, the plot looks like this one. So it is monotonically, exponentially increasing function, ending at 1, starting at 0, and it is a monotonically increasing function. So with this, we can say it is a valid cumulative distribution function. But other thing we can check that we can do differentiation of this given CDF function, we'll get PDF function, and we can also check it out the properties of PDF function. So done. In the next slide, start. Small fx of x is equal to d fx of x by dx. That is differentiation of CDF gives PDF. So fx of x are doing after integration, differentiation. So given function is 1 minus e power minus x by 2. One differentiation 0. Then left over is minus e power minus x by 2. Differentiation is minus e power minus x by 2 multiplied by minus half. So which gives 1 by 2 e power minus x by 2 when x greater than or equal to 0, 0 when x less than 0. So this whole property which required to check here is the area under the probability density function should be 1. That is minus infinity to plus infinity, small fx of x dx is equal to 1. So substituting the given, the evaluated PDF function in the equation, it is from 0 to infinity because less than 0, its value is 0. So 0 to infinity, 1 by 2 e power minus x by 2 dx. Doing integration, 1 by 2 constant kept outside. Remaining is e power minus x by 2 and the differentiation, that is minus 1 by 2 divided by minus 1 by 2. Substituting the limits 0 and infinity. So substituting the limits e power minus infinity minus e power 0. So which gives to 1. So 1 by 2 gets cancelled. Left over 1 is minus 1. So minus 1, e power minus infinity, minus e power 0, e power minus infinity 0, e power 0 is 1, minus 1 multiplied by minus 1 plus 1. This is how we can check the validity of the concerned CDF function and PDF function. Second one, B. Capital Fx of x is equal to 0 when x less than 0. 0.5 plus 0.5 sine of pi by 2 x minus 1 when x values lies between 0 and 2 and is equal to 1 when x is greater than or equal to 2. So the first two properties of CDF are fx of minus infinity is equal to 0 seen from the equation x less than 0, its value is 0. Fx of infinity x greater than or equal to 2 for all values greater than 2, its value is 1. So 1 can be seen from the given equation. Next, we have to check whether it is a monotonically increasing function or not. So substituting the values from 0 to 2, some random values I have considered here, or substituted fx of 0, which gives to 0 value. So you can see it from the given slide. 0.5 plus 0.5 sine pi by 2, in place of x we are substituting 0, sine minus pi by 2 minus 1, so its value is 0. Substituted 2 value leading to 1. Substituting a 0.5 gives some value 0.1465, fx of 1 and fx of 1.5. You can see the plot of the waveform. It is a monotonically increasing function. So I have plotted the given CDF from values 0 to 2. Less than 0, its value is 0. Greater than 2, its values is 1. Between 0 to 2, I have considered some good number of values, substituted in that equation and plotted. And it can be seen from the figure. It is monotonically increasing function. Its fx of x is monotonically increasing function. So from the waveform, it can be clearly seen that it is a monotonically increasing function. So it is a valid CDF. So alternatively, I can do it again by evaluating the corresponding PDF. So fx of x is equal to d capital Fx of x by dx. Doing the differentiation of the given CDF function. Use 0.5 cos pi by 2 x minus 1 into pi by 2. And just so the equation fx of x is 0 when x less than 0, and between 0 to 2, its value is pi by 4 cos pi by 2 x minus 1. The property of the PDF is that minus infinity to plus infinity, fx of x dx is equal to 1. Substituting the same, the limits from 0 to 2, pi by 4 cos pi by 2 x minus 1 dx. So evaluating the integral equation, you can see here sine pi by 2 x minus 1 by pi by 2, substituting the limits 0 to 2, and it leads to 1. So it is verified in both the CDF and PDF form. So we can check the properties of CDF, alternatively the properties of PDF also. Right. So this third one is an interesting one. So we'll see here. Fx of x is equal to x by a, u of x minus a minus u of x minus 2a. See here, it's u of x is unit step function. U of x minus a is unit step function delayed by a units. U of x minus 2a is unit step function delayed by 2a units. So you can see the plots here. This one is u of x minus a. Second one is u of x minus 2a. Subtraction of these two between 0 to a, 0 minus 0, 0. From a to 2a, its value is 1. From a to 2a, its value is 0. 1 minus 0, 1. From 2a to infinity, both are having 1. 1 minus 1, 0. So it's a simple rectangular pulse between a to 2a with magnitude 1. So this is u of x minus a minus u of x minus 2a. Now, this should be multiplied with x by a. If I take x-axis x with 1 by a slope, it is an increasing function. With a positive slope 1 by a, it is increasing a ramp function. Increase ramp function. When I multiply this with this function, finally I will get here from a to 2a with the increasing function with the x by a. Here x by a, substitute in place of x 2a by a gets 2 here. Here x is equal to a by a is equal to 1. So with 1 at a, 2a value 2, so it's an increasing function. So here we have to check the properties of the fx of x. That is, it is starting at 0, the first one is okay, but ending at 2, it is not a valid CDF function. It is not a valid CDF function. It should always end with 1, and capital fx of minus infinity should be, capital fx of plus infinity should be 1. It should be having 1, but when x is equal to 0 in this axis, we can say its value is 0. So it is not a valid CDF function. From the properties, we can establish this fact. So fx of minus infinity is 0, verified. Fx of infinity is 1, not satisfied. So it is not a valid CDF function. It is not a valid CDF function. So this is how we can check the properties of cumulative distribution function and probability density function. It should obey the properties which are discussed in the first session. So the second problem is that find the values of real constants a and b such that fx of x is equal to 1 minus a exponential of minus x by b u of x is a valid distribution function. Question is given that it is a valid distribution function. It is a valid distribution function. So find the scope of the values of a and b. Find the scope of the values of a and b from if it is a valid distribution function. If it is a valid distribution function. So fx of minus infinity is equal to 0 because it contains u of x, unit step function existing from 0 to infinity. Value 1 less than 0, its value is 0. So it is satisfying fx of minus infinity is equal to 0 because it consists of u of x function. Next one is fx of infinity should be 1. Why? Because it is taken from the properties. Is true if only b is greater than 0. If in this function, if b is greater than 0, then it will ends at 1. And it should be monotonically increasing function if a values lies between 0 and 1. A values lies between 0 and 1, then only it is a monotonically increasing function. Alternatively, we can also do one thing, that do the differentiation of this function. Differentiation of this function. U of x indicating that it is existing at x is greater than or equal to 0. So 1 minus e power minus x by b is given here. So the do the differentiation, 1 is 0, and do the differentiation of this function and integrate that function with reference to minus infinity to plus infinity. Then we'll get the conditions for a and b. That has been not done, can be done at home. So the third one is that find a constant b which is greater than 0 so that the function given small fx of x here is, it is a PDF function. It's a PDF function. Fx of x is equal to e power 3x by 4 between intervals 0 to b elsewhere. It is clearly given b is a value greater than 0. So we have to find the value of b such that this is a valid probability density function. This is a valid probability density function. So from the property, we can say that minus infinity to plus infinity, fx of x dx is equal to 1. Fx of x is existing from 0 to b. So integral limits from 0 to b, 1 by 4 e power 3x by 4. 1 by 4. So actually, I missed here. 1 by 4 is there. 1 by 4 e power 3x by 4 dx. So 1 by 4 with e power 3x by 4 gives 3 by 4, and substituting the limits b from 0 and b values. So 1 by 3 taken outside. The remaining thing is e power 3b by 4 minus e power 0 is equal to 1. So once 1 by 3 e power 3 by 3 b by 4 is equal to 1 plus 1 by 3 upon simplification. E power 3b by 4 is equal to 4. So apply natural logarithm on both sides. You'll get the answer for b is equal to 4 by 3 ln of 4. Natural logarithm of 4. Likewise, we can do good number of problems on the valid distribution function. We can find the values of constant. Only thing is proper integration is required to solve these problems. You know, integration, mainly if you have a functions of u and v, integration by parts. So you should know all those, then we can easily solve the problems related to the probability density function and verification of its properties. The next one is a random variable x has x bar is equal to minus 3, that is mean. E of x is equal to minus 3. X square bar, nothing but E of x square is equal to 11, and variance of x, that is a sigma x square, is equal to 2. And for a new random variable, say y is equal to 2x minus 3, question is given, find y bar, expectation of y square bar, expectation of y square, sigma y square, that is the variance of y. So we'll solve this problem. So given equation is capital Y is equal to 2x minus 3. Apply expectation operator to y. Expectation of y is equal to y bar is equal to e expectation of 2x minus 3. Separating the expectation, 2 is constant kept outside, expectation of x minus expectation of 3. We have seen in the previous session also, expectation of constant operator is always constant. So expectation of x is given as minus 3, 2 into minus 3 plus minus 3. So E of y, expectation of y is equal to y bar is equal to minus 9. The second one is expectation of y square, that is y square bar is equal to whatever the thing given for y is 2x minus 3. So expectation of 2x minus 3 whole square. Expectation operator 4x square plus 9 minus 12x. Separating the expectation operator, 4 constant, expectation of x square, expectation of constant is constant, minus 12 is constant, kept outside, the remaining factor is x, so we are representing it as expectation of x. Substituting the given values, E of x square is given, E of x is given. Substituting the values, 4 into 11 plus 9 something, will get the answer 89. Then variance of y, sigma y square is equal to m2 minus m1 whole square. M2 is expectation of y square, M1 is expectation of y. So expectation of y square minus expectation of y whole square. Just we computed these values, substituting the same, 89 minus 81 is equal to 8. So likewise, we can do the problems on PDF, CDF, and calculation of mean, variance, standard deviation, nth order movements. The movement here requirement is only the integration formulae. If you know the integration, you can do successfully all these problems on PDF, CDF, and operations on random variable. So that's all for the end of lecture 3 and completion of week 1 MOOC of this 4-week MOOC course on stochastic processing. So in this week, we have discussed the random variable, properties of CDF, properties of PDF, operations on single random variable, calculation of statistical parameters such as mean, variance, standard deviation, and nth order movements, and some problems, some calculated problems mentioned this in this lecture 3. So that's completion of this week 1 session. Week 2 session will discuss a joint probability density function and operations on multiple random variables. So extension of single random variable properties onto two-dimensional random variable and two n-dimensional random variable. Thank you.